What is mind one? What is one mind blowing? All right. Hold on. Pause, bro. Come back. Yo, this happens, bro. This happens.
Okay.
All right.
Ian. Everybody's talking about jurisdiction. Everybody really good. Excellent.
Today, we're going to be asking physics PhD students random questions, ranging from the hardest questions in the universe to questions about movies and time travel. Let's see what they say. All right, so what's your name and what do you do research in as a physics PhD student?
All right, so my name is Isaac Svedberg. Currently, I'm doing the research rotation, so I'm not really sure what group I'm in yet, but I'm leaning more towards condensed matter physics.
What's your name and what physics are you interested in?
I'm Nicholas Klein. I'm interested in, I guess I would say, quantum information stuff right now.
I'm Nick Terahoff. I'm a physics PhD graduate student, and I'm interested in theory mostly, but I'm not sure where I'm going to find myself.
Any general area you might be interested in, like astro or condensed matter? What's
Condensed matter, particle, that kind of stuff.
What's the most mind-blowing physics fact that sounds fake but is actually true that you know of?
Probably that momentum can be transmitted through thin air, like in a vacuum, like electromagnetic fields. Like that's just mind-blowing, like how it can just travel without a medium.
That's kind of crazy, actually.
Yeah.
Like just the fact that there's nothing in between and it still transfers.
Just energy, momentum, anything just travels through thin air, or just not air at all, and just transmit energy without a medium.
What's the most mind-blowing physics fact that sounds fake but is actually true that you know?
I think GR is pretty cool, and I think that we can actually see the effects of GR, mercury, perihelion. It's pretty interesting.
That is some cool stuff. That's true.
Probably quantum teleportation. I mean, that's one that's just, it does sound fake, but you can transport information from one place to another faster than light. There are some technicalities there, but that idea is pretty mind-blowing, I'd say.
That is cool. Yeah, true. All right, what's your name and what sort of physics are you interested in?
Okay, so my name's Stephen Colleran. I'm from Boston, Massachusetts. Park the car in Harvard Yard. I don't have that much of a Boston accent, but
You don't like a
My dad
good
does.
hunting type?
Yeah.
Like my boy Wicked Smart.
Yeah, no, not at all. But
My boy not Wicked Smart.
but yeah, I'm mostly interested in like material science stuff, specifically two-dimensional materials.
My name is Harry Lopez Morel, and I'm interested in condensed matter physics, specifically electronics, probably.
What is one mind-blowing? All right. Hold on. Pause, bro. Come back. Yo, this happens, bro. This happens.
Okay.
What is one mind-blowing physics fact that sounds fake but is actually true?
One mind-blowing physics fact that's actually true and not false. Actually, statistically, according to statistic mechanics, you can actually have a small chance of actually putting your hand right through this board right here. It's very, very small. Pretty much.
What's it called?
Quantum tunneling.
Tunneling.
Yeah, look up
Quantum
the YouTube
tunneling.
videos. There's definitely a YouTube rabbit hole you can go down for that.
I'm gonna make one on it.
Perfect.
Yes. If you could completely solve one physics mystery, what would it be?
Probably quantum gravity.
Quantum gravity seems like the easiest bet.
Having some sort of complete description of quantum gravity would be nice.
And I guess this will be like, well, most people will say it will be like M theory of everything kind of stuff.
The current problem of a room temperature superconductor.
Quantum gravity, that's the big one, right? Quantum theory of gravity. Yeah.
Fair enough. And if you could get an equation named after yourself, what would that equation be describing?
Quantum gravity.
I was gonna say
quantum gravity. Yeah, probably something like that.
fair enough. Svedberg equation actually rolls off the tongue pretty nicely.
My wife's name is Sparks, so it'd be the Sparks equation. Took her name.
Is she a physicist?
Could be. You never know. Computer scientist.
physics and computer science have a pretty good overlap
Yeah, I
there.
mean, the Nobel Prize is in AI, so
True. If you could completely solve one physics mystery, what would that be?
Quantum gravity would be nice, if that's even possible. That sort of grand unification, that's like a theoretical
Yeah.
pipe dream.
So everyone wants to solve quantum gravity so far.
Yeah, I mean that's like the
That makes sense. Yeah, that's like the Nobel Prize, the question of the century, essentially.
I mean, to know if it's actually quantized or not, to see if it's like, do we need to change a whole section of our physics? Because it seems like we have two
Yeah.
distinct topics that we know very well and can predict a lot about, and we apply it all the time. But to connect the two, it just doesn't make sense right now. So I think that'd be probably, I mean, that's what most physicists are aiming at nowadays.
Yeah, being able to describe all like fundamental forces and how the universe works pretty much, and just like like making the standard model fully accurate. I don't know.
Yeah.
The biggest thing in condensed matter, which is the stuff I study, which is pretty much a study of solids and liquids, is the current problem of a room temperature superconductor.
Oh yes.
So what a superconductor is it's a certain really weird conductor that allows no resistance going through. When you put a current through, you use your copper or whatever, you lose about 33% of it.
Yeah.
33% of the
So with the
energy,
superconductor,
you would lose nothing.
you would lose
In
nothing,
theory,
and that would
yeah.
basically save a lot of energy. Is
Oh,
what you're
save a lot
saying.
of
So it'd be a
energy,
huge
yeah.
change to the
especially
industry.
especially because gas
Why
and
can't it be at
everything.
room temperature right now?
Right now, it's needed at very very low conditions. Superconductivity, to how we know, is only about 80 Kelvin, which is very 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 cold.
So solving that would be your
Yeah, that would be, and
best thing.
yeah, I would say that would
What
be
equation? So what would the equation be? Is
the
there an
equation.
for that, or
Yeah, I mean there isn't
maybe
known.
like a superconductor. You'd call it the
Yeah, exactly.
Stephen.
Yeah.
How many all-nighters have you pulled for maybe physics studying for exams or just for homework?
probably max one. I actually value my sleep a lot, so yeah. I mean, I've stayed up until 3 a.m. before doing physics, but I haven't pulled an all-nighter, I don't think.
And is the 3 a.m. pretty common, or is that like maybe once a month or something?
Once every 2 weeks, maybe.
How many all-nighters have you pulled for physics? I know you're a big all-nighter guy.
Yeah, sometimes, no, countless. In undergrad, I did spend a lot of time not respecting my home health, but it's super important. When I got into grad school, I'm surrounded by a bunch of people who know how to manage their schedules, and I'm starting to do that a little bit better. And
good.
I don't think I've done a single all-nighter this semester.
That's
or
good.
last.
Improvement. Or last.
Or last.
I feel like in grad school I've been able to have a better like time management of myself than in undergrad.
Good. So
I feel like I've reached a time at which like I'm more comfortable with like, this isn't fully done, but it's not worth it for me to like put an all-nighter for it. So I think the only times that I've slept only a little bit or nothing at all is like
before exams, maybe.
yeah, before
Yeah.
exams. And I sometimes have come like super early to the grad suite to like study for quantum.
What
or
is
something.
super early for you?
That's when like Jake and I will wake up and show up here like at 3 a.m.
Jeez.
So I think I'm very unique in this sense. I've never pulled an all-nighter. Actually, I've never stayed past midnight studying. Mostly because I in undergrad I ran track, so I always had 8 a.m. practice. So if I did
insane.
pull out an all-nighter, it would never work.
Midnight. Like that's
Yeah.
normal.
Yeah,
That's insane.
yeah,
For
and
undergrad, that's insane.
yeah, I just never stayed that past.
Yeah, I definitely-
Once I hit 11 o'clock, usually I usually just I like to get at least 9 hours sleep before every exam. I think that is going to do better than studying for another 3 or 4
That's
hours.
true. That's true.
So 0 in grad school.
That's
and
good to
I'm
hear.
going to keep it that way. I don't want to do all-nighters.
Fair enough. Fair enough. But how about undergrad then?
In undergrad, I had at least 2. There might be a couple I'm forgetting, but yeah, at least 2.
Okay. Was that for exams or homeworks?
One of them was like this big report I had to write, and I didn't have enough time throughout the day. So I had to
Fair enough.
spend all night doing it, and that was not fun at all. So I mean, it wasn't
So-
too bad, but I didn't get good sleep. That's for sure.
If you could give one sci-fi movie a physics accuracy check, which one would fail the hardest? Like any physics moments in
Yeah.
movies that are just terrible that you can think of?
First thought, easily, when we're watching Interstellar, when he falls into the black hole, the huge black hole, and he gets transported to some kind of dimension. Yeah, it's not really clear that that's like an alien, like put him into a 4D space. You're dead if you're within the event horizon. So that happened before he got into the event horizon, likely.
Apparently, yeah.
You
we
are
don't know.
dead. Your time is going like your position is, and your position is going like your time, which probably that's a good fact that we could say. For
That is a good
the
fact.
last one.
Have you ever seen Moonfall?
I've heard of it. I've never watched it,
That
but
one's a really goofy one.
goofy.
I don't know how bad the physics is because it involves the moon coming closer to Earth and people get sucked up into the moon. And I just
Yeah, I don't
see
think that
that's how it would
happens.
work.
Yeah, I don't think that
But
happens.
I think that one would not fail, or that would fail the physics check off.
If you could give one sci-fi movie, or anything sci-fi fiction that has like a bad physics moment, something you've watched and you were like, that's not exactly like true in physics, but would have probably gone over most people's heads, maybe even some of the physics PhD students. What movie would that be?
Well, as a math major, also in undergrad, there was one part in the Endgame,
Avengers Endgame.
I think the most sold, like most gross profit movie of all time. And they have this Mobius strip thing, which...
One last sim before we pack it in for the night. This time in the shape of a Mobius strip. Invert it, please.
Processing.
Right, give me the eigenvalue of that particle factoring in spectral decomp. That'll take a second.
Yeah.
Wow,
When
so-
like Tony Stark was like, oh, like let's time travel, but like we'll use a Mobius strip.
Yeah.
Like he just
That's
time travel
nothing.
using-
That's
he just
absolutely
did some-
nothing.
Yeah, I think he did something about like the eigenvector or eigenvalue of a Mobius strip. He just said that, and then like everyone in the theater was like, "Whoa!"
Yeah,
But,
no,
like,
it means
me and a couple of
absolutely
my
nothing.
friends were like,
yeah,
"What?"
it's just putting a bunch of like
Jargon.
jargon.
Yeah,
Exactly.
yeah.
Yeah. Keywords that people would like. Oh, like I've maybe heard of those words. Those sound difficult. They mean nothing together.
True.
I think the more, at least the more general stuff that I don't like is when movies mix jargon that just has nothing to do with it. Like, oh, we need to use the nanotechnology of the quantum destabilizer to
Oh
do the whole, and it's just like you just mix three different concepts that do not have anything to do, or like three entirely different subfields. Like these things do not even have to do with each other. I don't know.
Do you think time travel is possible?
No.
If so, why? And if not, why not?
No, I don't think so. I think that, well, it has to be demonstrated that it exists. I mean, it would be awesome. It'd be really cool, but just the idea of either, the imaginary mass or the negative mass thing. Negative energy density makes sense. Like, that is a totally valid... So what that is you have a capacitor that's really, really small, and let's put it in the vacuum of space with some kind of background temperature called the cosmic microwave background. It generates an effect that's opposite of the radiation that is on it, and so it ends up having what's called a net negative energy density. It basically means you've made something that's a fake negative mass, which doesn't really make sense.
But you need that for time travel.
It gives rise to weird effects like time travel and going FTL, faster than light.
Well, to my knowledge, I've never taken a GR class before, but general relativity. Sorry. To my knowledge, you can travel in the future, but you can't travel in the past. So,
like if it's possible, it would only be to the future.
Just to the future. At like high gravity, it's like kind of like Interstellar, when they go on the neutron star, like they travel in the future. But it's just like gravity warps time. So,
Gotcha.
So yes, it is possible.
All right.
But just not in the past.
Okay. And for the final question, I'm gonna ask: do you think time travel is possible? Why or why not?
I'm not going to say it's impossible. It seems very hard to do. I mean, it would break a lot of the laws that we know.
Mm-hmm.
It's really hard for me to think about like how physics would play out.
So
going like back in time or even forward.
In how many years do you think we're gonna solve the time travel question?
Oh, I don't know.
Is it gonna be like a couple of generations or like many, like 1,000 years?
Yeah, I think it would take a while. I don't know. I mean, maybe we could expedite things with machine learning or whatever.
Fair enough. AI is making pretty crazy strides. Yeah.
It's hard to say. I mean, at least like, and there's no way it's gonna happen in my lifetime. I don't think.
Fair enough. Yeah. No. 100%.
At least longer.
It's
than
not
that.
gonna. Yeah.
Yeah. Like and subscribe.
Oh yeah, like and subscribe.
Join the Patreon.
I don't have a Patreon.
If we invent time travel, we'll have a Patreon.
That's true. If we invent time travel, I will go back in time and make a Patreon.
Mhm.
Like and subscribe. Like and subscribe.
It's free, and you can change your mind at any point in time, and it really helps me out as well.